This conference will now be recorded.
Yeah, hello, Prashant, Venkat. I think Eldo is not yet joined.
Yeah.
Okay, let's get started. Okay.
Okay.
Anyway, Ansible part I'll show you at the end of the session. So now we will focus a little bit more on high availability, decommissioning and all. So then after some time we will focus on Ansible also. Okay. Uh, so let's get started. So here, so we have seen how to add a host. Okay, so adding a host is called commissioning normally, and also the cases like where we need to remove a host from the cluster. So the prop we need to if you remove the cluster immediately, like shut down and take it out, so there won't be much issue because our cluster is designed to have a high availability in place. Like if any of the data blocks which is stored in this host is lost, still it has option like the copy will be available on other worker host. Also the similarly the job also, if any job is running on that host, like so it should be moved to some other host. So here we will see how to remove a host, so that we call as a decommissioning. Okay, you can just check like so there is a documentation.
Your session is not shared. Desktop is
Oh,
not shared.
sorry. Okay, sorry, I was not sharing. Yeah, sorry for that. I hope you can see the screen. Okay, see, we were talking about the decommissioning. So decommissioning is the process of taking this whole one of the hosts from the cluster properly. So open the Google and you can just see Hortonworks documentation will be there. Okay, so decommissioning a slave node, official documentation from the Hortonworks. Just have a look at this. Okay, so prerequisites, what are the prerequisites? How to decommission node manager or data node, and if HBase is running, how to take that out. So the thing is, like, if you have a proper outage plan or proper plan to take the host, do it in a proper way. Otherwise, like if the data block which will be stored here, and again it has to, so cluster has to take some time to get that replication in place. But still, if workers are available, enough workers are available, definitely there won't be any data loss. However, if you have a proper outage plan, you can have that. Okay, so the decommissioning is like uh, we have a proper plan and we are taking that host. So there may be things like you need some hardware maintenance, or you just need to remove that host from the hardware itself. So we can do this. So the first is what are the prerequisites, right? uh, See, you need make sure like appropriate properties are defined, like exclude file is there for HDFS and yarn, but actually that is not needed, so we can directly go ahead and do this decommission steps. Okay, and for decommissioning data node, how to do that, steps are here. And uh, so what you have to do here is, on the name node, just exclude add the data node host name. Okay, and see, it will be there in the decommissioning progress, and you can just refresh this, or else I think graphically there will be an option like you go to the action, data node decommission. So you have an option to do it in a graphical way also. I'm just going to decommission this data node. Okay, so first to go to the host menu, then go to the action, selected host, and the data node. Just use decommission. So decommission means I want to decommission the node. Like so, this will do an HDFS decommissioning process. Just hit OK. If you expand that, you can see. So what it is happening here? See, DFS exclude. You can see in this file it's adding that entries, and so if you just go ahead and see, look this file here. See, the worker 4 is added here. See, whatever the things we do it in a terminal way, you can do it in a graphical way here. So and also you can see it's doing a DFS admin refresh host. See, this is the command it's doing. Like here you are asking like DFS admin refresh node. So you can do it in a terminal way, or here in with the help of Ambari you can do. I always recommend to do with the Ambari. So if you want to decommission an HDFS, first hit that, go to the action, selected host data node, just decommission. We already did that, so I think decommission is in progress, and you can see this file, where this file is located. This file already will be there. You can go to the HDFS configs, and see this is the file etc hadoop conf dfs.exclude, and this is the same file we just checked, and you can see the host is worker 4 is available here. And also for yarn there is an exclude path available. We can just check that. Go to the yarn, see this is the file. We will just see what is the content here. Is there anything inside that? See, the file doesn't exist. So for yarn decommissioning, this file doesn't exist. Then, but still, we will just check how to take the yarn service away. Okay, so go to the host. You can see it's in decommissioning state. Here we have an option like okay, so we will just see a node manager. Okay, so node manager is the worker component for the yarn. So what we need to do is add this in the exclude path. Like so here uh, the directory is yarn.exclude. Yarn.resource manager .nodes.exclude path. So we will just check this option. This is the yarn client. Yeah, node manager. We have an option like decommission, because actually the node manager is a worker component. So we need to decommission. So one option is get that files like configuration file and add. But when we check that file, that doesn't exist. Okay, so job exclude, this exclude path. So under advanced, so this is the file. So one option is, so we can manually add the content to that file to uh, exclude, or just to take the yarn node manager from that. But this file by default doesn't exist, but you can create that and add. But if you want to make that with the help of Ambari, you can do. Go to the host and select the host where you want to do that. Then if you click on that host, you can see the node manager. The client component and all, you need not to worry anything because it's all just executables copied. So node manager, come here, just to the decommission, right? So actually, if you just expand these steps, you can see what it is doing, and uh, this is adding that into uh, just conf file. And now, if you just check this file, I think exclude. I don't know, maybe it's running on that particular host, master 3. We will just see on that host. Just see here. This is the IP. So load that and just yeah, on this host, okay, where we excluded, but on the master it's not created, but on this host it's created and executed the same command in the decommission step, just yarn rm admin refresh nodes. So this command has executed yarn this to config file path, then rm admin refresh node. So this is also done from the Ambari. So there are two options. One is from the Ambari, or the second is the terminal based approach. But if you have an Ambari managed system, so you can use this option. Just go here, we have an option to decommission or commission the components. But all other components or the client components you can directly remove without any issue. Just you can just remove all these components, or even if you're not stopping, that is fine. But HST agent, I think we can stop and delete. Just stopping. Then metrics monitor, that is also stopping. Then HDFS client, these are all clients. Clients doesn't have a daemon running, so you cannot see any stop options. So this is still showing in a decommission state. So if you look into the name node URL, okay, so decommissioning data node here, if you can see that. So name node URL 50070, and if you just check in that, I think in our case, the name node is installed on uh, 133. What is 133? That might be the master one, right? Yeah, just take this IP. So 50070. 50070. Here, if you go to the data node overview, and here you can, the safe mode is off, then live node for decommissioning node is 1. Okay, one node which is in decommissioning state. So during the decommissioning process, so you have to wait some time to get this process completed, because during the decommissioning process it will move the data blocks to some other worker machine, so that the replication factor is maintained. So for example, we have uh, 4 or 5 hosts, right? So it will be part of the worker host, I mean HDFS, and in that case, if any data which is stored over there will have to move to other machines. Okay, like say for example, I have workers like this. Maybe this is one worker, another worker, and this worker. And this is all part of HDFS worker. That means data node service may be running, and it's all stored some blocks. So for example, if this is a file and the same block, or this is a part of file and the one block. So this block may be stored here, here, and sometimes here also. And if you have a replication factor, DFS dot replication, that is set to 3, so it has cluster has to maintain 3 copies. And if you are decommissioning this one, and this copy has to move to some other worker machine, so during the process this data movement will be happening, and until the data movement is completed, then the status will be decommissioning state, and it has to wait some time to get this done. Once the complete data copy is done, then decommissioning will be completed and it will show the status as decommissioned. So it will be varying based on the data size it is storing. And decommissioned, nothing is showing, down, nothing. So worker 4, okay, so it's we'll just check. So this is still showing us a decommissioning. And once this is done, it will show as a decommissioned. So once this is done, okay, once decommissioning is done, so you can just select the host and select host. But you just select the host, then delete host. Just hit that option. The host cannot be deleted now because maybe okay, the following components are running and need to be stopped. So but in real case you have to wait until this is completed. So, and also I cannot. I'll have to stop this service once the decommissioning has completed. Okay, I'm just stopping. But actual case, you have to wait until the decommission process has completed. Okay, but right now I just went to the host and stop that data node service. Okay, but still my decommission process has not completed. Go to the action, selected host, delete the host. Okay, so once you stopped all the services, all the components, you should be able to stop this. Just go ahead and hit next. Just to type delete and confirm. Okay, now the host is deleted. But remember, in actual case, you have to wait until this decommission process is over. Then only you should be able to do that. Okay, so this way you can just remove the host. And now if you check here, worker 4, it's still showing here, and it shows as it should show us as a decommission and wait. But the problem is we have not waited until this is done. That is the reason it's still showing there. But if you just stop or restart the some of the services like name node and all, so HDFS service, if you restart, then I think it will show only that 3 host. Let me just restart all the HDFS components here. So now you can see only live node is showing 3 only. Decommission and all it's still not showing. The reason is we have removed the host. Okay, so 2 options are there. One is okay, so we have seen like how to decommission from the documentation. So what you need to do before that, you need to make sure these config files are there, but by default AutoWorks is having these 2 config options available, but you need not to manually add anything. The second is like if you are removing one second. Okay, so HSpace region also, but in the documentation they were giving the text-based option, like update in the file that whatever the host name, and DFS exclude also. But if you are doing with Ambari based, you can do it with the help of Ambari itself. This is clear, right? So any questions?
So Satish, basically,
Satish, can we do this decommissioning, uh, data node decommissioning after adding all components? Then we can know that how it is impacted on other components also.
Sorry, I didn't get that.
Actually, see, now we have added only HDFS and MapReduce only some
Correct.
components only. So what
Yeah,
I'm thinking,
uh,
can we do this one after adding all components like HBase and other components so that we can know how it will impact on all things?
yeah. HBase decommission. Only the other components and all fine, because the way we are doing is only for worker components. Okay.
Yeah, okay.
So, but other than that, only the HDFS only we need to wait and do this operation. All other slave component we can immediately do. It won't affect
Yeah,
much. Even HDFS
okay.
also won't affect. But only thing is, we were just waiting to get the replication ready. But while
Okay.
running the job, if you decommission the node manager, still
Uh-huh.
the job will rerun on the some other working node manager. I
Yeah.
mean working yarn component.
Okay. Okay.
And but normally if you do the master component decommission, but you should be very careful, because the
No.
master components you have to move to the another host separately, then only you would be able
Uh-huh.
to do that. But
Okay. Okay.
HBase also, I think it's written here in the normally we try to do that. HBase also, HBase region server, that you need to stop the daemon service. Okay,
Okay.
HBase region service has to stop. But this also we can
Okay.
do in the graphical way, just to stop that service and
Uh-huh.
do that.
Okay. Okay.
These three only we mainly need to focus. Other than that, but normally in production environment and all, we won't keep any master components on the worker host. So worker host is mainly HDFS worker component, that is a data node, and the yarn worker component is node manager, and the HBase is HBase region server.
Yeah.
Other than that, all other components you need to be stopped.
Okay.
And also, but if you do it forcefully, nothing will happen. Like I mean to say, but for some time, this under replicated block issue will be there, but it will automatically recover. But the better way is to do it in a proper decommission. So any other questions? Prashant, you were about to say something.
yeah, sorry. So usually what happens when I've seen that where take example that where we have got more master nodes,
Mm.
and if I want to remove one of the master node, because I don't remember that I have seen any documentation for that. So what should we do? Because we need to move the services, etc., isn't it?
For that, I think there is an option. Let me just check. There is an option to move the services between. Uh, 1 second. So we have option to move a name node, secondary name node from one to another. Okay. So, but I think if you have a HA in place, that will be better. So, a name node you can move. Okay,
Mhm.
from one host to another. And the yarn, I think resource manager, which is the master component, that also you should be able to move. Okay, so these four are, I mean, moving is feasible. but it's very rare we do this operation. But however, if you have a serious hardware thing or anything, because of that we need to move, so we should be able to move the services to another. We can just try that. And here I think we can option to move zookeeper also. We have option to I think here I don't see any move option. Okay, so most of this master component will support. Let's say let's just try. So we have the name node here, right? So I think the name node is in the master one, so we
But
can move that.
I think we won't even move because we haven't got the availability available, isn't it?
Yeah. Okay, the following services will be restarted as part of. Yeah, but still this option support. Okay,
Does
so
it?
right now this is the master, and we have that option. We will just try that. Okay,
Yeah.
later. I tried this option some time back,
What
but
did you?
not in production environment. But in
Yeah.
production, we don't have much issues to move. But in a test environment like this, I tried that.
All right. That's good. Okay. Understand. Yeah.
Yeah. And another thing is, okay, so we have a name node and secondary name node. Okay, but what happened if anything happened to this name node, and our entire cluster will become not usable. I mean, so HDFS service will be down if the name node goes down. Still we have the secondary name node, so which is available, but a secondary name node will just helps us to do the checkpoint. Okay, so we have a name node, we have secondary name node, right? But it's not a high availability one. Name node and secondary name node, the mostly people get confused. But name node, secondary name node is not for high availability. High availability in the sense, if one goes down, immediately the other one should be up and running. Okay, this is HA. But HA is secondary name node, and name node is not a high availability option. But the role of the secondary name node is to help in the checkpoint operation. Okay, then you may be thinking, what is the checkpoint? So checkpoint is the process of taking the backup of a name node. Okay, see, we have this option. So for example, the name node. Okay, this is the HDFS architecture. So name node will store all its metadata in its memory, RAM we call. Okay, but the reason why it kept all the metadata information in the sense like where about the data, how these blocks are placed, what is the replication factor, what is the permission, complete metadata will be stored in a physical memory. Okay, the problem with the memory is if the system is down, then everything will go. So if you make some changes to the file, or if you upload a file to HDFS, physically it will be distributed into data nodes, right? And but where it's stored, all this information will be stored into or updated into the RAM, because the RAM update is easy, unlike a hard disk writing, and also access is also very faster if you use your metadata in RAM. But the problem is the persistency. So it has to save it somewhere or do some checkpoint so that later if the cluster reboot or anything happen, how to recover that. Okay, that we can do with this checkpoint operation. So what it happened is, like as I said, it will store the information it's in memory, and that will be periodically saved into a file called fs image. Okay, fs image is the file system checkpoint image, and also there is another file called edits. So you need to understand what is this two file. So you can see these two files in your cluster, some name node location. So fs image is just a checkpoint of your RAM. I mean RAM for only for name node. And whatever the operation, like if you are from Oracle background, you have redo logs, right? So redo log will keep writing. Whatever the operation happens, it will be written over there. See, consider the example. We have some name node metadata, which is here. and we have a corresponding FS image. That means this is in the file format and this is actually in the, so both are same. Say for example, if any operation is happening, it will update in the metadata. But the same thing, whatever the operation, it will write into a file called edits. So edit file will be keep growing. So in case if any crash happen, so we have a FS image. So this FS image, we apply whatever the operation which is written in edit. So finally you will get an updated image. So which is same as this name node metadata. So but the problem is, if your edit file is keep writing and it will grow like anything. And if you have a large sized edit file, then okay, so for example, you have FS image which is taken some time back and your edit file is growing and you have very huge edit file, then whenever you want to do an recovery, so loading FS image into a memory is comparatively faster, but applying this edit will take a lot of time. So the problem is, if you have a large edit file, then this will take a lot of time. I mean, applying whatever the operation in the edit to here. So what the cluster do? So cluster will take this FS image periodically, so that it will have the latest FS image and a small sized edit file. So that operation is called checkpoint. Okay. So checkpoint means what it do during this process is, checkpoint will just take the the copy of this into a file that is called FS image. That is the latest one, and then it will start writing in the edit into a new file. Is this clear or still confusing? Let me explain a bit better way. Okay. So say for example, this is name node metadata. So say for example, this is in the RAM, and we have taken the FS image. Say for example, this is at 10 o'clock. Just for reference, I'm just writing the 10. Right. So definitely at 10 o'clock, if anything happened to the system, we can load this FS image into the memory or copy this FS image to another host, install the name node component, and if you just recover that, you can just reconstruct this metadata. After 11 o'clock, you have the name node metadata. Okay, so this is the 10 o'clock. But on the top, we have some changes happen, right? Whatever the changes happen, they are recorded into the RAM and another file called edits. Okay, in between whatever the whatever the operation happened, so that is written into edit. But also in memory, what is the changes happen? But we have only FS image which is taken at the 10 o'clock and this edit file. So for example, something happened to the 11 o'clock or 11:05, if the system got crashed, everything gone. But I have a edit and FS image. So my FS image is taken at the 10 o'clock, but after 10 to 11, whatever the operation happened, I have it in my edit file. So what I can do, if I just want to reconstruct, just to load this FS image. So that will have the value till 10 o'clock. So this value, what you can see this gap, I can do by applying this edit. Okay, 11 o'clock, whatever the operation happened in between 10, I can reconstruct by using applying this edit. So that is about FS image and edit. FS image is the persistent copy of file system namespace, and edit is a file which will record all the edit operation.
Hello?
Yeah. Is
Sorry.
this clear?
Yeah.
Okay. So yeah. So the problem with the very old FS image and the large sized edit is, in case of recovery, this applying edit will take a lot of time. Okay. So applying this edit, we have FS image file or which is taken at long time back, and we have a huge sized edit. So applying edit will take time. So in order to overcome this, what we will do, at 10 o'clock we have an FS image. Okay. And at 11, say consider this 11 o'clock. So we have this FS image plus edit, right? So what it will do, it will take the FS image at 11. Okay. So that means that will be and so if you have the FS image at 11, so you need not need this hold edit. So you can have a new edit file. So after 11, whatever the changes happening can record here. So this is the way the checkpoint work. And the check for doing the checkpoint, we need a secondary name node. Okay, so we have a name node. We have secondary name node. So what will happen? Like so, it will do the checkpoint with the help of secondary name node. So secondary name node. Okay. So what it will happen? Secondary name node will copy. Okay, secondary name node will copy initiate this process with the help of secondary name node. So first it will copy whatever the FS image and edit file. By that time, it will start writing into a new edit. Okay, so edit file, it will start writing into new edit file, and whatever the FS image and edit file which have so far copied to secondary name node. So what secondary name node will do, it will load this FS image and apply this edit which is copied from here, so that it has a up-to-date namespace. Then it will take the latest FS image here. Then that image will be copied to here. So this is how the checkpoint will happen at very high level. So actually the secondary name node is doing this operation, getting this FS image and copying it into the name node, so that we still have a latest FS image and relatively thin edit file. So, but in this case, we have edit and FS image latest available in the secondary name node, but still manual effort is needed to make it as a name node. So the secondary name node is not a HA option. So if you, instead of the secondary name node, so if there is an option like standby name node. Okay, so standby name node do the same function of secondary name node plus HA, high availability. So if anything happen, so this will also act as a name node. So we will see how to enable that option from here. So go to the, yeah.
Sorry, can we go back for a second? I just wanted to clarify something. So that's fine. That I understand that it builds the same FS image and edits file on secondary name node. But
Correct.
does it copy from secondary to primary? The master.
Yes. Yes.
So what is the logic? Because the same thing is happening on master anyway. Because
No, master. I mean, taking the FS image won't happen in the master. I'll tell you why the master needed. Okay, let me just redraw the diagram. Okay, so we have a FS image at 10 o'clock, and we have edit at 10 o'clock. So now, say for example, after 10, it says started writing into a new edit, new. Okay.
Yeah.
So this is having a, metadata. Maybe at the 10 o'clock, we have a, metadata. This is just a logical representation. Say for example, this edit file is sometime back, and FS image is sometime back, and whatever the operation happen after that is available in this edit. So these two will move to the secondary name node. Okay, then it will load this FS image here and apply this edit so that we will have a latest namespace. Okay, so which is the same as this one, but only thing is after copying this or after this, whatever the new changes here will be writing it into a new edit file. So now once this is done, what it will do, it will just save this namespace into an new FS image. Say for example, FS image 11 or whatever it may be. Okay, and it has the old FS image and old edit. From the old FS image and edit applied to this one, and then only it's saved, and that will be copied to here, so that FS image and we have a new edit file. So why this is using is when you restart the cluster or restart the name node, so it load this FS image and whatever the changes after that apply to that, and so that we will get a latest namespace.
But this is this portion which you just explained just now, that I'm not able. So because the secondary name node, or in this case, which is standby name node, standby name node is not used anyway. So here, whatever we are getting in a second standby node, we are getting the updates happened on master, right? So standby name node is not running, is running, but is not kind of in.
No. This is secondary name node, not standby.
It's not receiving any active transactions, so there wouldn't be any updates here. Then what is the
Sorry.
point?
No. Doing this operation, like saving the namespace and all, require I think read-only mode. Okay, so we cannot stop the cluster for doing that, or for the checkpoint to happen. Okay, say for example, why we need this machine is, say for example, if I want to take or save the file here itself, then no operation should happen here. So it has to be in the read-only mode or save mode. Then only we can save this namespace. But the cluster is still running, and during that time, so we need to take the backup. Is that clear?
No, I think so. You know this second step. Can I don't know how to point. You know, where you have written on the standby name node, where you have written the copy of standby, a copy of FS image and edit file from standby node is going back to primary again, master node. Yeah. I don't.
No. FS image, this is the latest one, not the same one.
But why that needs to go there? That's my question.
No. Why this is needed?
Yeah.
So we have the new edit file, and so suppose if you restart this name node, which one you use? So if you use the old FS image and old edit, it will take a lot of time, right? So the reason why we are using the,
but they are not old, they are new, right? Because assume for a second you don't have standby node, right? Assume for a second, okay? And your FS image and edit file there keep FS image is is being, every new FS image is being created every few seconds, right?
No,
And
no, 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 it won't create. Only the edit file will be there. FS image creation will happen only at the secondary name node side because we cannot do it while the cluster is in operation. So to save this namespace metadata, then in name node should be in the standby mode. Sorry, not in the standby mode. I mean to say read only mode, safe mode. So this FS image taking, okay. So first, okay, I'll just show here how this. So for example, you just format the name node. So initially you will have an FS image, okay,
yeah,
and after that there will be a lot of transaction happen. So that will be recorded into the file called edits. This is clear, right?
yeah,
So this will be created when your name node is getting formatted, and after that whatever the transaction happen will be written into this edit file. Also your metadata is also get updated, which is nothing but the RAM. I mean, if
yeah.
you stop your machine, so this will go. So next you have to reconstruct the same thing. You can reconstruct the same thing using this FS image and edit. So but the problem is this will keep growing based on the number of transaction happen. So edit file will be at a kind of redo log file that will expand, or the size of this file increase if lot of transaction happen. So in order to, so the problem is if this size is growing, so if you just want to reconstruct this, or if you just restart, so what will happen? It will load this FS image, whatever the latest FS image available, load into memory, and then whatever the edits available, apply that edit into that memory.
Is this FSMS is in another mission or in the same mission?
No, 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 no. Here we are just talking about the prime name node only. Okay, we are not yet. Discussed about secondary name node. So when you format a name node, initially FS image will happen, and whatever the transaction will be updated to edit file. Consider there is no checkpoint happen. What will be the problem here is this edit will keep growing. The size of the edit will be very high. So if you restart this name node service, what it will happen? So it will initially load this FS image into memory, whatever the latest FS image available here. Say for example, this is the one, and apply this edit to this memory. So in that case, if you have a huge sized edit file here, then this operation, restart a starting operation will take a lot of time. See, while starting, you can see it will be in the safe mode when we apply this edit here, right? So that is the reason if it's taking the safe mode quite long time, that means you have a huge sized edit file. So what we need is, say for example, okay, so we know we have the namespace, latest namespace available here. So this one we can save, right, FS image. But the problem is to do this operation, the name node should be in the safe mode. Okay, without the safe mode, you cannot save the namespace metadata. But in a working cluster, you cannot keep your cluster in safe mode in between, or frequently you cannot. So what we will do, we have a secondary name node. So that helps to do this operation. How that helps is, okay, a secondary name node will have identical configuration of name node. So what it will do, it will take the FS image from the uh, working one and whatever the edits. Okay, then when this happen, it start writing into a new edit so that it will have relatively low transactions. Okay, so these two files it will load so that this is almost equal namespace metadata. Then secondary name node can go into a read-only mode or read-only mode or safe mode. Doesn't affect our transaction because all our transaction will be happening during this time also. Then once this is applied, so we have the namespace which is similar to or same as this primary one. Then it will save this file into new FS image. Say for example, FS image 2. Okay, so we have a new edit, and if you copy this FS image 2 here, the FS image 2 plus new edit is the same as the latest namespace. So now if you restart your name node here, so it will load this new FS image and a new FS image and apply the new edit only. So this is relatively lower in size, so the transaction or the startup operation won't take much time. Is this clear?
Yeah.
Yeah, clear.
Still it's confusing?
No, that's fine. Understand.
No, the reason is okay. So the first thing people will think, okay, so why can't we take this FS image here itself, right? Why you need a second image? Why we are copying this FS image and edit over there, loading there, and say, I mean taking the file and copying back here? The reason is to take that checkpoint, it should be in the safe mode. So during the safe mode, the operation won't work. So we cannot, do that because our cluster may be running for a long time, and there may be a lot of jobs or other operation running. So that is the reason we are copying this FS image and edit, load there and get the latest one and copy back here. And now we have a latest FS image and latest edit. And after some time, again what it will do, so it will copy these two here, and it will start writing into another edit file and load it here and save that file, again copy back here. So this operation will continue periodically. So this will happen every 1 million transaction or every 1 hour. So based on which one is happening first. So every 1 hour this operation will, again this is configurable parameter. So this checkpoint transaction you can just see here from the HDFS. Just check. Yeah, this is the 1 million, and DFS name node dot checkpoint transaction. This is 1 million, and what is this? DFS trash interval, not this one.
Up there, I think HDFS maximum checkpoint delay. Is that one?
Yeah. Yeah. So this much second. So what will be the hours maximum checkpoint delay? Yeah. So otherwise we can forcefully take this namespace metadata, but that require safe mode. Okay, so let's just go to the HDFS. So just see HDFS DFS admin. Now you can see save namespace. Okay, but if you just do that, see, this is asking us to just change it into safe mode. Okay, so that is the reason, like we cannot save namespace means whatever the namespace metadata will be saved, but this require our cluster to turn on the safe mode. Safe mode is just like a read-only mode. Okay.
And where get then? So where that namespace information gets saved in metadata database, or it's in the FS image itself?
No. Here it will be saved into our location. Okay, let's just try. there is an option like DFS admin, safe mode. Just enter. Then if you just see safe mode get, it shows like whether the safe mode is on or not. Then you can just see the save namespace. Then now safe mode it should leave. If you just go to slash, so the directory where this is storing, you can get like checkpoint directory. I think this is the secondary name node directory, and so it will be in the slash Hadoop only. You just go to slash Hadoop and HDFS name node current. This is the FS image, and this is the edit file which is in progress. So like you can see a lot of old edit first image and edit file, right? So this is all you can see just a 1 hour delay. But in our case, our scenario, we just we are not keeping the cluster for a long time. Otherwise, every 1 hour it will be just keep changing this FS image file every 1 hour or whatever the time we have mentioned there. And in the secondary name node, if you go to this directory where you can see these files. Okay, I think a secondary name node is running on master 2. So where is the master 2? And get that IP address. You go to slash Hadoop HDFS. So here name node secondary. Okay, I think these all files are not copied so far, because I have to keep the cluster for a long time, or if it's a transaction is happening, then it will make use of this. Okay. Now we will see how to add second standby name node. So we have seen like secondary name node, but normally in production scenario and all, we will use a standby option, because we have the same with the same cost, we can build a standby name node. So normally we want to keep the secondary name node over there, but you can just remove, or just I mean during the standby deployment, it will remove the secondary name node. So just to go to the action, just select name node HA, and here you can just add some name service ID. So for example, if you just so HDFS DFS hyphen DF hyphen H, if you just use, so here it's showing like a master1.hadoop.com and 8020. But in standby case, okay, so we have two servers. Okay, okay, we have two name nodes, name node 1 or name node 2. Okay, each one has its own host name. Say for example, this is master 1, this is master 2, and maybe 8020 is the port it's running, and 8020 is the port where this name node is running. But we need a logical name, okay, and that will be mapped to either of this one based on the availability. So if this is available, and instead of this one, we will use this namespace colon namespace itself. We can just write, and that namespace will be resolved to any one of the working one. Like in our normal load balancer and all, we use some logical host name that is resolved to any one of these. Similar way, it work here. But here we have only the single master one. We are just using this option. But instead of that, we need to have a logical name. Say for example, I'm just writing name node HA. Any name you can have. So depending on your choice. And you need to have an additional name node. So we already have a name node which is running on the master one, and the second name node where we want to, I can just choose master 2. And there are other hosts, okay, which is available in high availability. They are called journal nodes. So okay, so this is the name node, and this is the standby name node, and we need a set of node which are called journal nodes. We will install this as this is running as a daemon or service. So journal node is responsible for shared edit. So you all have seen like we have FS image, and then whatever the transaction is happening, if this is active one, definitely there will be some write and read operation will happen through this one, and whatever the transaction is happening, it will record into this. And journal nodes will have some directories, and all the edit files will be synced over to that journal node. And journal service, out of 3, at least 2 should be up and running. So that is the majority work based on the majority rule. And the standby also connected to this journal nodes, but here the connection is the read connection, not the write connection. Standby cannot write into the journal node. So whatever the transaction is happening, that will be recorded into the journal nodes, some edit location, and here also on the edit location, and the standby will read that and update that it into its namespace. So for example, a name node and standby initially load from the some earlier taken this file fs image. Later whatever the transaction, okay, initially this two has the same namespace. After that, one will be active. So with the active one, operations will happen, like users will connect or application will connect and write something. That transaction will be recorded into, so I mean all the transactions are edited here into the journal nodes. And the standby will read those journal files and apply it to here, so that the name node and standby name node has always the latest up-to-date namespace metadata. Okay, so that is why we need a journal node. So journal node is responsible for shared edit, but the minimum recommended value is 3. The reason why it's using 3 or 2 into n minus 1 or something, or else we just need odd number only. Just remember, the journal node we use only odd number, not even number. The reason is, even if you use, like for example, if I just use 3 or if I just use the 4, so it work based on the majority rule. So majority means here out of 3, 2 is the majority. Out of 4, the majority is not 2. 2 means the tie 3. So that means here if 1 goes down or here also 1 goes down, still the service is available. If you have use 3 journal node or if you use the 4 journal nodes, the failure it can withstand is only one host. However, if you use the 5, out of 5, majority is 3, right? So that means if 2 goes down, still you have. So that is the reason always odd number is recommended by considering the majority role. So journal node is responsible for shared edit. So active one will be writing into journal and the standby one will read from the journal host. And second is we have a zookeeper failover controller. So zookeeper failover controller daemon is a part of zookeeper which will run on the active and standby name node, and it's responsible for automated switching over or automated switching to from active to standby in case of active one goes down. So we have a zookeeper failover controller and journal node, active and standby name node. These are the part of name node HA. Okay, so these are needed for name node HA. So we will just try to configure that journal node where we want. So we will just add it in the master 1, master 2 and worker. So normally I think we have a master 3 also, right? Or do we have yeah, I'll just add it on the master 1. Yeah, master 1, 2, 3. Yeah, the master 1, master 2, master 3, all the journal nodes are here. Now if I click next, here you can see the secondary name node will be removed. Okay, and it will install additional name node here and the general node on this host, and the remaining configuration this is just a read only option. Just go ahead and hit next. Then so this is not a fully automated way, so you need to manually do certain steps. Okay, so this is saying log into the name node host master 1 and put the name node into safe mode and save namespace. Then only this will this one you can see this is not active at this time. So what we will do, we will go to the master 1 and switch to, sorry, okay, let me just take that again. Master 1, okay. So now what we need is just see, you need not to do like sudo su hdfs -lc, because here it what it's saying, like switch to hdfs user and execute this command. So now we will just use this one and add it here. Basically we need to log in as hdfs user and execute this command. That is what it's written here. Otherwise if you are doing from CentOS user, you can just do the entire thing. So basically, so it's asking us to use as an hdfs user and execute this one, and once safe mode is done, save namespace. Okay, that is done. So you will be able to proceed enquiry detect name node salesman, right? Just hit next. Okay, so that is done. Go ahead and hit next. Now, this is again saying go to the master one and execute this one. So this is like initializing shared edit. And you can see this is not prompting us to go further until I complete these steps. So go to here. So since I already have HDFS user, I can just do initialize like this way. So once that is done, okay, yeah, that is done. Then hit next. Now again, so it's saying like log into the name node master1.hadoop.com and see format zookeeper failover controller. So the first step, what you need is execute from master1.hadoop.com. Just take that and execute. That is done. And the second steps, or this is written as log into the master2 and just execute this step. So this one we have to do from the master2. We have this host, just switch to HDFS user, then execute. Once that is done, we are good to go. Okay, next. Please confirm you have run the manual step. Yes, okay. Now this is getting started. So you can see this is completing the reconfiguration, and whatever the configuration changes and all, it's doing in the backend. So basically, we just added one more name node, and which is standby name node, and along with the deployment, it will create a service called journal node, which will run on minimum 3 hosts. And journal node is responsible for shared edit. So the active one will be writing it into the directory that we mentioned in the journal node, and the standby one will read from that location. And we have another service, zookeeper failover controller, so which is responsible for automated failover. Like by default, if any in case of any active one goes down, the standby will automatically switch to active one. So that is done with the help of zookeeper failover controller. If zookeeper is not running, then there will be a problem. So we need to manually do that switch over. So there are certain steps involved for that. So you have to do. But if zookeeper is up and running and working properly, so it will do in an automated way. So for example, if you stop the active name node, then the standby will automatically take that control, and standby become active one. So that doesn't require any manual intervention. Now this is done. If you look into the HDFS menu, you can see standby name node, active name node, zookeeper failover controller on these two, and 3 data nodes already there, and 3 journal nodes. And now if you go to here, HDFS DFS -df -h, you can see earlier it was showing node 1, node 2 like that. Now this is showing name node HA. So if you can just use HDFS DFS -ls/ this way also you can use, or you can just use this ID, like say for example HDFS DFS -ls then user like this, or slash also. Now as I said, like if you just see one is running standby, one is inactive. So active name node is running on master 2 now. Now what I'm going to do here is I'm just trying to stop this active name node. Just stopping. So definitely the service should be unavailable, but if you just see here, you will have the service available. But even though active one goes down, we don't see that issue here. Now our active name node is down, but immediately the other one become standby, become active. So now if I just I can just turn on this one, just hit start, but this time this will be in the standby only, but not the active one. So the earlier active one still will be active, but this will change it to standby. You can just wait and refresh for some time. This is the standby, right? Now if you just hit and see here, or if you just use the same thing, dfs-ls/, this is also same, but if I stop this standby will become active. Just let me just stop this one. So now if I am stopping this, in the standby is automatically changing to the active one. Now you can see, so this will work even though here it's taking some time. So this switching from active to standby, if active is down, then the standby will changing to active. So this is done with the help of zookeeper failover controller. Is this clear? So HDFS, I hope HDFS high availability is clear. So we mainly add high availability for the name node only, but the worker host already we have um, a failure. I mean availability in place. Like we have a multiple data nodes, and each data node shall have a a different data nodes will be storing the block, and we have a block replication in place. So that ensures like the data node is available, but this way we can have a standby name node. So if active one goes down, the standby will come online and will work. Okay. So now let's see the high availability for yarn. So normally yarn have components like resource manager and node manager. You can see mainly the resource manager and the node manager. The resource manager is the master component, and node managers are worker component. Like we have a name node and data node. So we might have multiple node managers available. If some of the node manager goes down, still we have our job running on other host with the help of other node manager. So for node manager, failure won't be an issue, but timeline and the other thing are just for keeping the history and all those things, but that is still not that much important in case of your running job. But for getting the job details and all, it's needed, that we will see later. But the resource manager is mainly responsible for running your job. Like say for example, if I just stop this resource manager, definitely our cluster or the job won't work. If I so now it's running, maybe while running itself, let me just stop this one. Now it's stopped. You can see this is not progressing. And also if you just resubmit the job, it won't run, it will stuck there. Here you can see. So just getting the timeout error message. So if you see this message like retry to maximum with the file sleep, connecting this failure, that means your resource manager is down. So you can just start this resource manager. So that means the resource manager is single point in failure. Like if the resource manager is down, and you won't be able to run the job. Now just started. Now see, once this is started, then our job is just started. So we again have the single point in failure for resource manager, like I said. So we can add multiple resource manager. So that is called a resource manager HA. And here the configuration is all very easy and straightforward. Just do enable resource manager HA. Hit next. Add the node where you want to add the resource manager. So this I just choose master 1, or else just use master 2, wherever we want to add this second resource manager. Hit next, and here you can see RM1 and RM2. So these are the host, master 3 and master 2. and hit next. So here, unlike the name node HA, we don't need to add do much configuration. Just doing the thing easy, straightforward. Just choose the host where you want to add this additional resource manager. Okay, so now okay, I think this is done, completed. That's it. So here also uh, you can see one additional resource manager is added here, and if one of the resource manager is down, the other one will become active and will do. But here also the zookeeper will place in backend and it will do that. So now if we just submit a job and just doing it in a okay, just so 100 mapper and 100 samples per map. So this is a very big job, and this is selected master 3. So okay, so it's used master 3, and which is nothing but this active one. So I'm just turning off this active resource manager, and we'll see what will happen to our running job. Okay, so active one is down now, and but this time the standby will change to active state. Now if you come back here, So this should progress. Maybe some few seconds delay will be there. This is active, and then okay. So thing is, the post to the deployment should restart some of the component. Maybe the configuration files and all may not be properly updated. Like, let's just now you can see the job is progressing here. So 18% to 26%, and it started running. Okay, let me complete this restart and see. So the resource manager HA is very simple. Just add that additional resource manager. That's it. So if active one goes down, the standby one will run as an active one. So even your job won't get affected. So in between, if active goes down, then the standby will change it to active state. So any questions? Okay. Now you can see the job is running well. Let's stop these instances now, and so did you get a chance to test Ansible?
Not
Okay.
yet.
Okay, no problem. Yeah, for Ansible to do, you need, I'm not saying you need not to have a very higher end setup and all. So you can do it in your own VirtualBox based environment, because it doesn't, unlike a Hadoop environment, it doesn't require a higher end setup. Just doing SSH between the host and all. So I just did from this VirtualBox setup here, and you can do the installation and then test it. Okay. The only thing is understand how Ansible work. So what are the important file? But the professional way, they do it in a separate coding style, like Ansible playbook only. But they will write into a different directories and keep it as a different module. So we call it as Ansible Galaxy, and where we write different roles and all. So we won't write everything in a single file, but that will be like so different YAML file for different tasks, and we call that file uh, from our main script. I'll just show you some of the steps I have done earlier. Sorry, this is, and also you can download OS boxes. I think so there is a website like osboxes.org. So you need not to install the images and all. So you can download the image here from here. Just to go to this website osboxes.org, and you can just check VM image, whether VirtualBox or VMware. So let me just choose this VirtualBox, and under here you have different operating system. If you just hit on the CentOS, so download VDI, and it will show various versions that you can download. And also here you have VirtualBox or VMware, whatever you want you can download. And 7.18 different versions are there. And the last tab, info, is about all about the password and other credentials. Just a few size MB VirtualBox you can see. Better choose 64-bit, download that, and install VirtualBox software and open that and run. So what I used here is the same thing like a VirtualBox image only. So just open that file. I think file somewhere host. I think a new. Then see, you can choose this file, whatever the file you have downloaded. That you can, I think, an existing virtual disk file you can just choose. Okay, so this is the file which I downloaded from the VirtualBox, and you can clone this VM, right? Clone, and that reinitialize the MAC address and next link to clone so that it won't consume much space. So once you have done that, you can start testing. Like you can deploy multiple VMs and get the IP address and all, and you can either graphical way you can connect, or if you know the IP address 192, whatever the IP it support, 192.168.1.8, I can just open with the putty. So 192.168.1.8. Then OS boxes, that is a username. Password is osboxes.org. Then I can switch to root. Where I kept. I don't know where I kept on this one or Docker single. Let me just open the another one also. Use this detachable start option. Like normal start, sometimes it won't work. Okay, so here the IP address is 192.168.56. So 192.168. Here I can see I have okay, it's all okay. So here you can see one file. What I use is like this inventory file. You can just write this inventory file like this. You can use, I mean to say, rather than using the default one, you can write your own file. Just I written as master Ansible host. What is the host name and connection, and what is the user and what is the password. So earlier we used key-based authentication, but this time we are using the password-based authentication. And YAML file. So this is the install.yaml file, and so this portion, okay, first before writing this playbook, you need to know what is YAML file and how to write. So hyphen means, if you see hyphen means that is the list or array, and other than that, this is just a key value pair. So this is one play. Similarly, you can write, okay, one play means one module that I mean, write. See, like you can say second play. Okay, so under that we can return on which host this set of roles to I mean set of instruction to apply. And here I have written the roles again. So you can write into a directory roles, and you can define different roles. So this is all different directories under roles directory. But I'll show you how that. If you just see the roles directory, you can see under CM repo for MySQL and prerequisites. So if you just see the prerequisites, under that we can write different tasks. So I'm just see the main task, right? See here I used yum install. I think it will be confusing if you just read this immediately. But what I'm saying is this is the way we write, and with item means it's a for loop. So yum will do the installation for HTTP and NTP. So if you have multiple packages to install, you can write it over here. So with the yum, and also the firewall disabling for VM's happiness changing, and disabling. All these things you can automate it with the help of this file. Okay. So the simple test you can just do like so this is the role, and Ansible, we call that as an Ansible Galaxy, but the role we will call, like without this also we can have that task directly with the task option that we have seen yesterday. I'll show you a few more from the starting from the scratch how to do the different testing, but right now just understand how to do the installation and how to do the simple test. We can gradually build that. Okay, so any questions or any help you needed, let me know. I will you can just message me on that group. I'll reply to you. Okay, just at least try to install and try to learn the basic things. You can also see, I think tutorial point is the best to start Ansible. So this is having very from the very basics, like what are the things you need to learn, what is a YAML and all those things. I will slowly show you a few more example and exercise the next week. But right for the next week, you just do the installation and basic test. Okay. So any other questions?
Suresh, what I was thinking that can you send some like these sort of, you must have compiled these commands somewhere or prerequisites somewhere, so that if you can send that document or that sort of commands you must have written somewhere, it will be easier.
Okay, for Ansible. All right,
Ansible
right.
or prerequisite or somewhere, because we need to write down these prerequisites, isn't it? The way you have written down there.
All right, all right. I'll give you that. Okay.
Yeah.
Also, the
Okay.
documentation, I need to prepare a few more things. I'll just try to share that
Yeah.
also. Yeah, sure.
Sure. Thank you.
Yeah. All right.
Right.
Okay. Good day.
Yeah. Thank
Thank
you.
you.
Okay, thank you. Bye bye.